All right, so here's the deal. Second step is the slow step, so that is the rate determining step. So we take and we go, okay, the rate, based on the rate determining step, some constant to change them back and forth, concentration of AB, concentration of C. That makes sense, right? Because it's the reactants that determine the rate. Good so far. Okay, second step. However, we have in here an intermediate. We have to get the intermediate out. And we have to take into account that there's an equilibrium in the first step. So what we're going to say is we're going to say that the rate forward equals the rate in reverse. Right? And so the rate forward would be K, concentration of A, concentration of B. The rate in reverse would be K, concentration of AB. Does that make sense? Because if you think about it, if you're going this way, these are the reactants. If you think about it that way, that's the reactant. Okay. Next piece. What we're going to do is we're going to solve for this intermediate that we have to remove. In this case, the solution's pretty easy. All we've got to do is take that K over. So let's call it K1. So we've got K over K1, concentration A, concentration of B. Good? So then the last step is to say, okay, here's AB. Here's AB. We want to get AB out of there. So we're going to rewrite the equation, taking all of that and placing it where AB is. So the rate overall is going to look like this. Rate equals K times, this is a different K over K1, times A times B times C. So all of this is what we just substituted in for AB. You see it? Yeah. So what's going to happen is any intermediates have to be eliminated. We have to take into account the first step, the phase equilibrium. So we're going to substitute in this. Now what you'll start to see is it becomes pretty easy to do that because you look at what's on each side and you just, write that's equal to those two and then replace. Okay, it'll get easier. It just requires practice.